Gimmelberg are part of our core team. They'll be answering questions along the way. And I'd invite you, just as some housekeeping, to go ahead and ask questions as you have them at any time during the presentation. Matthew and Eugene will be answering them. And to start off the presentation today, we have Torsten von Eichen, our co-founder and CTO, who's going to lead us through the introduction, which will then culminate in a demo. And just one word before I hand off to Torsten. We're really focused in these webinars on providing content-rich, practical information on how to leverage the cloud for your needs today and gain the benefits of cloud computing. So welcome again to the webinar, and Torsten, please go ahead.
Hello, everyone. This is a little bit the agenda, and we're going to focus mostly on the demos. So the idea is to make it content heavy and show real things and not slideware. So I'll talk very briefly introducing what the demo is about, and then we'll show a scalable database, so scaling it vertically to larger servers and rolling out a minor app server upgrade. And at the end, we'll leave plenty of time for questions, but please use the chat now to start asking questions. We'll be launching servers. That takes a few minutes, and there should be time for us to answer some questions in the middle. So we focus quite a bit on the life cycle of servers, and especially multi-server deployments. We've talked quite a bit in other webinars and in conference presentations about the design phases, using server templates to design the servers as opposed to machine images that in one big blob contain everything, very hard to manage and to iterate, to change, and one-click deployments. Today we'll really focus on managing things that happen once the deployment is running and something happens, right?
It always does, yeah.
So we identified 4 main use cases or scenarios, and we'll talk about 2 today, and we'll leave 2 for the next time, just so we have actually enough time to get through the demos. The first one is demand growing, and so we'll take a database system and upgrade that to larger instances. And the second one is rolling out a new feature, doing sort of a minor upgrade to app servers. We'll talk about a major upgrade, so basically relaunching everything from scratch almost in the next webinar, and also some failure cases. And I'll come back to some of the details here, but I really want to go straight into the demo in order to, so we have time to launch something, and then we can continue some of the talking. So the setup is as follows. We have 6 servers in this RightScale demo site, 2 front-end load balancing servers with the round-robin DNS hitting both of them from browsers. And they hit app servers that are behind them. And it looks like I forgot 2 arrows, so each load balancer really hits both app servers. Should be arrows crossing between the 2. But the important thing is in the back end we have 2 databases, MySQL master and a replicated slave. When we started, we were budget conscious, so we launched them on small instances. Those are half-core, 1.75 gigabytes of memory EC2 instances. And things are getting hot, so the master is starting to get somewhat overloaded, and we want to upgrade to larger instances. So what we'll show you is launching a large slave. So this is taking a large instance and launching that, and bringing it into replication with the existing master, so it is current and has all of the data. And once we have that, once that is running properly and everything is looking good, we can fail over the app servers to the new master. So basically promote the new machine to a master and do a failover. And at that point, we'll be running the app on a more powerful database. We won't be replicated, so following that, we need to launch a fresh slave database so that we again have our replicated database set up. And at this point, it's really a total upgrade of the database tier. We still have the old small machines running. That's the beauty of the cloud. You always roll forward and use the next resource. The old ones are there in case something goes wrong along the way. We can always go back and fall back to the old master, old database, and keep operation while figuring out what went wrong. So, Ed, are you ready?
I'm ready for a demo. So let me slide over the screen that we've created. Make it nice and centered here. So if you're unfamiliar with the RightScale dashboard, this is the top level. When you log into the account, you get to see all of your deployments. So one nice feature is you'll notice down here on the bottom, I have some deployments v1, 2, 3. These are just backups of what I was working on before I got my final deployment. So I have copies of that. The only active one with servers running is demo deployment. So if I click on the word, it highlights.
And so each row here is a server. So we have our 6. You have a 7th one.
Right, we'll talk about 7 here in a minute.
Okay.
Remember, the round dots are running servers and cost money. The square dots don't cost money. They're simply definitions that if in the future I have a problem, I can always roll back and use a different version. So I'll drill down. Now I'm inside the deployment itself. I have to pause to make sure I don't interrupt the audio while we're changing the screens very quickly. Let's talk about these extra guy right here called HTTP load tester. I've added one extra machine 6 minutes ago to this deployment that simulates user load, because we want to demonstrate that this set of machines are actually under load. So if I go into monitoring, we'll see that about a couple minutes ago, the load started. Okay, so you can see I've actually put a lot of I/O load on my master database, and it really is time to graduate. At 50, I'm about half the performance of that volume. So it really is time to move up to a large. And with these plots, which I can see at the deployment level, I can actually see not just one server, but any of the servers in the entire deployment. So here's my load tester generating load. You can see it actually does a lot during boot, and now it's generating load. This is my master server's I/O interface. This is mostly responding. It's getting a little bit of requests, mostly replying. And all the other things in the neighborhood, how the load balancers are working, the fact that I'm hitting both load balancers. Great way to know what sort of load your servers are under and analyze the need for what I'm about ready to do, which is to take this master server right here, that's the master database, and I'm going to convert him into a large. Step one, I did before this presentation, was I backed up everything. I have a backup of my databases, I have a backup of the deployment. Step two, I drill down into my operational running master. What?
Me too, just wait a second. No, just going to change.
Oh, I see. Oh, I can see over here when the screen's changed for the users. Very good. Thank you, Dustin. So now, this is my master database. He's operational. He's actually being used by that load that we're seeing. And I can see that load inside the monitoring, which we already saw. And I want to clone him because he's on a small database. You can see he's a small. In order to preserve all of the information I've set up with this database, all the parameters, all the configuration, I'm going to clone him. So I click on the clone button. And I create a new copy of my master server. Note the new server is not operational. It's just the definition of the server. And I'll immediately change his name to master copy. No, new slave. Be better? New slave. That way I'll know that it's a new slave that I'm creating. Okay? So I click on OK, and it'll be shown in the deployment as the new slave, but I won't get confused. But some of the information that I've inherited by cloning is not correct. I want to make it larger. If I didn't want to make it larger, I could just launch right now, but I do want to make it larger. So I'm going to go select a new image. I'm only interested in RightScale images, and I want to use the new 64-bit beta. This is the latest version of the 64-bit operating system. The availability of its own chain stays the same, but I don't have the right instance type. I'm still in a small. How big do you want to go here? Medium, large?
Large. The medium is actually 32 bits, so we need a large.
M1 large. Okay, we're now going to graduate our server to be an M1 large. Save, and I get one more chance to check. Let's read carefully. I'm going to create a new slave. It's going to be an M1 large. It's using the new 64-bit operating system and inherits all the information from the previous one. Time to launch. I kick launch, and you'll see on the left-hand side of the screen,
You need to click launch at the bottom.
right, we have to say okay to all the parameters. That I've in fact launched a new slave. Now this is going to take a moment, so I'm going to send it back to Thorsten. He's going to talk a little bit more, and then later we'll come back and our new slave will be pending and then operational. Once it's operational, we can continue. So expose back the screen to you.
Great.
Shall we pose a few questions here?
That's
Go ahead.
great.
Great. So a couple of questions have come in, and while that deployment is launching, the first one is, why 2 load balancers?
The 2 load balancers are for redundancy. This way, there are 2 instances, and they can actually be in different availability zones, or think different data centers at Amazon, so that should one go down, should there be a problem, really the second one is available and continues to handling the load. The failover between the 2 is done using round-robin DNS, which means it's really on the client side. In other words, your web browser, both IE, Firefox, Opera, and other browsers have, Safari have built-in failover, but it's not perfect, so that's why it's still a very good idea to have real load balancers that can deal with more, with faults that may occur more frequently in the app server. And we'll do a fault, such a failure in the next demo when we upgrade one of the app servers.
Okay, great. Next question, can you use the same load balancers for multiple arrays of different app servers, and should each array be in its own deployment?
Yes, you can. And can you just go to the deployment? Oh, you don't have any arrays in here, so right. So at the bottom, this is simple for the demo. One of the other demo deployments we use has an array of app servers at the bottom, and you can add multiple arrays to a deployment, and load balancers can certainly be configured to hit both of them or to hit them for different vhosts. And all of the config, that's a good moment to say that all of the config of all of the servers is really available to you. So when you use one of our prepackaged server templates, everything we do is really visible, and you can, just like we cloned the server, you can clone the server template and make changes to it, such as adding another vhost to the load balancer server template, and doing whatever you need. So here you see at the bottom the one array. This is the sales demo, I believe. So if you call up one of our sales guys, he'd be happy to demo this one to you that does auto scaling based on load. And at the bottom of the screen is the auto scaling array. It looks like right now it doesn't have anything running.
Okay, here's another question. When will general availability for MySQL EBS support be there? When is it out of beta, or is it stable enough now to move existing production environments to the MySQL EBS setup?
It has been stable, but we found a couple of minor glitches, and we have an update ready that I believe will be ready next week. So we're releasing new version of the website on Monday, and depending on how things are going, how busy we are with catching minor issues, we'll have the EBS, MySQL on EBS ready next week.
Great, and there are plenty of questions here, so just let me know when we're ready to continue.
Well, the slave server on the left in the recent events is still pending. Pending means that Amazon is currently allocating the server and loading the boot image, the file system up. It has been going on for 4 minutes. Why don't we go back to the slides, and we can then start the other demo. So we'll simply let this launch, and we can go forward. Actually, I had another. Why don't you go to the next slide? Yeah. So I thought it would be worthwhile just reviewing what's happening right now. So this is a little zoom in on the MySQL EBS replication setup. At the top left are the two app servers that are hitting the MySQL master, the small in our demo database server. So the way we use this is each sorry for the glitch. Each database server has its own EBS volume. EBS is like a SAN disk storage array in the cloud. You can allocate EBS volumes from 1 gigabyte to 1 terabyte in size, and you can attach them to instances. Each volume can only be attached to a single instance at a time. It appears as one of the block devices, so you can create any file system you want. We have one EBS volume per server, and what we're doing now is on the right-hand side, we've launched the new slave server, and automatically server template or at boot time, it creates its own EBS volume, and it populates the EBS volume, initializes it from a snapshot that was taken from the master. So when you set up a slave database, you need to get an initial snapshot of the master before you can really start replicating the replication process that then updates the slave with any changes happening on the master. So all the things you're seeing in green here are now happening automatically as the new slave comes into operation and creates the volume from this last snapshot on the master, and then contacts the master to start replication. How are we doing? It's
starting time zone now.
It's starting to boot. Can you just flip to the next slide here? We have two screens, so it's a little bit flipping back and forth. Let's keep going so we can. You're ready to switch to the other demo while this keeps booting?
Absolutely. I think we can do both demos at the same time. So we'll wait for the master to be replaced by a new slave, but the fact is that the demonstration I'm going to do only uses the old master. So let's do the second demonstration while the first demonstration is cooking.
Good. This one is a little bit simpler. We're going to do a rolling upgrade of the app servers, and the prerequisite here is that the app allows a rolling upgrade, meaning we're going to upgrade one server, one application server at a time. So at certain points in time, the old and the new version will both be running at the same time. Obviously, this isn't possible for all upgrade scenarios, but very often when you're doing minor changes, in this case we're changing some CSS of a PHP website, it really doesn't matter. It's nice to be able to upgrade one server, double check that everything looks good before hitting the others. And again, it's the cloud, so if there was a problem on the first server, we would essentially just abandon it right there and launch a third one to take its place back with the old version, and go back and then worry about the one that went wrong later after we're back in full operation. If you just go to the next slide. And then upgrade one server and then zoom through with the others.
Okay. So what I'm going to show you is what happened typically is in deployment. First they tell you to deploy one thing, and then they say, well, we need to upgrade the software to something new. So I put up the demo site, and of course the first thing they said is the background is too plain. The colors look pretty good on the top, but we really want to make this have a better skin, Ed. So we need to upgrade the software. So we'll go back and I'll show you how to go through a software rolling upgrade. What you'll see is that lovely little website will now change into a much prettier one. So I'm going to drill down into my first app server. which is an operatable app server. It's actually running right now, serving those pages you're seeing. And I'm going to run one of the scripts that's available. Okay? First thing I want to do is change that script. So instead of the standard, which is deploying the A-type website, which was the original, I'll go down here and I'll edit to try the new, already tested by my QA department.
So this is the list of all of the input variables that are consumed by the server template. So all of these are configuration entries that can be changed on the website and that get moved from one server to the next if you're cloning. And this is a nice way on the website to keep track. It's all version controlled. You can go back and see what happened, who changed what, etc.
So if we did everything right, when I get down to my operational scripts for SVN checkout, you'll notice there's been a B replaced with the A. So now the B-type website is going to show up when I push the code out. This is a classic code push. So you'll see, once again, another items come up on the left-hand side. We queued an SVN push of the code. Now, very important point. Go back to info and launch a look at our website from the EC2 volume name, not through the load balancers. Because if I go back to the load balancer, I may just get the other app server. I want to make sure and look at this app server when I'm done. Because when that queued request for an SVN checkout completes, this server alone within the array will be hosting the new code. See the blinking correct? It's completed over here. So our new web server is now launched with a new skin. Let's see if the new skin looks better than the old.
That didn't look good. Whoops.
That doesn't look too good. So we'll do a refresh. Okay, we'll try one more launch. Any guesses out there as to why I have a problem? The CSS file didn't come out. So we're cached on the CSS file on this browser. So there's a control or shift click on this one to get no caching. Shift click? Yeah. Hold on a second.
Step one, let's launch another browser. And
yeah, if we launch IE, we won't have this caching problem.
Let's give it a shot.
Okay.
Do you want to move it to the left screen so that everybody can see that?
I don't want to see that. There we go.
Minimize that. Yeah.
There we go.
And then move it to the left.
While you're bringing that over, Ed, there was one question I wanted to throw out, which is, can you give some customer examples of people who've had to use that kind of technology?
Yes, this is very, very common when you change the cascading style sheet, which unfortunately was cached. We had to launch a different browser to get the uncached version. Anybody who deals with web pages knows about the problem with caching cascading style sheets. And you're going to go, for example, from your summer catalog to your winter catalog.
Yes.
So you're going to change your cascading style sheet to your winter when the snowflake's falling from your one from the summer. So what we've seen here is a very classic update of the website from A, the original one done by the developers, to B, the one that Markham liked better with all the pretty pictures.
Even for code changes, oftentimes we do that update when it's a minor code update where there's not fixing a small bug somewhere, where there's no change to the database, nothing major that interacts with other systems, then that's the easy way to do it.
Actually, it's interesting with this application as part of WordPress's configuration is a pointer to the database and a prefix in the database. The actual new site here is using a separate database table from the first one. So I could have actually done a major database table flip. But it isn't seamless because I actually moved to the B-type database from the A-type database. So here it is, a standard SVN checkout.
That's nice. By the way, for those of you who can see that, Torsten is the guy on the bottom.
That's Torsten.
Yeah, second from the right-hand side. Ed and I did not make the casting director's cut.
Yeah, the headless people across the top are actually all the VPs.
So, and in a way, just coming back to the hiccup here, I think this was about the limit of pull up another browser, do a couple of checks. Otherwise, I would have asked Ed to clone the server that's still functions properly, app server number 2, clone it, and launch it afresh so that we have a fresh second app server running, and then take the next hour ahead to figure out what went wrong on number 1. It's the move forward. Just move forward. Don't try to fix it.
Right.
Here we sort of started down the slope of let's see whether we can. Well, we didn't fix it, but at least try to figure out what's wrong. But
actually, our customers would have seen the same problem with the style sheet because they would have their sticky caching. So we have to remind our developers to lower that TTL on that style sheet. Good point.
I think I saw the the new slave in operation there 7 minutes ago.
So let's get back to our first demonstration. Okay, not confusing people. We're not going back to our first demonstration. We've cooked up a new slave server to our master, but this slave is different. So I'm going to go to the new slave and show you that he's in fact different.
So he's been running for 9 minutes.
He's been running. He's now a large, not a small anymore, right? And he's a slave to the master. Okay? So I'm going to show you he's a slave by running an SSH console over here.
Make that a bit smaller.
Yeah, there we go. And we will shrink him down so we can see things. And type a few MySQL commands to prove to myself before I go any further that in fact all the databases are there. Could I check? Because he hasn't attached himself properly to the master yet. So that's what's so nice about this system. I haven't harmed the users in any way, and I've noticed that my slave didn't attach properly to the master yet. And I can give him another kick and see what happens. Because what I'm seeing here is a big empty database.
Is not set. There's that setting where they should automatically initialize since you're flipping back and forth, preparing the demo.
So this command tells the server to try once more to init himself to a running master. We know the master is running, so we're going to give him another kick and tell him to do it again. So he'll attempt to attach back to the master. You go back to my database, it's important you quit any running MySQLs while this is happening, because it's going to restart MySQL once it's reattached to the master, and we'll see that the master is working correctly. And the way I can tell, of course, is by seeing my WordPress databases accurately represented on the screen.
So we didn't upgrade the other app server, but maybe it's the same button press, so it might not be worthwhile. There's a bunch of questions that have come in.
Yeah, let's set some questions while we're doing that.
What happens if you must upgrade the database schema? Yes, you don't want to upgrade the database schema on one app server from one app server and be in inconsistent state. So that is definitely a scenario where you can't do such a simple rolling upgrade.
Yeah.
So what we end up doing is first divide any database changes, migrations, as they're often called, into a number of sets. There's often some you can run before taking everything down. And so you run them first. So this is like adding a new table that nothing is going to use yet until the code is upgraded. You can do that beforehand. Adding an index can usually be done beforehand, things like that. Then when the second set of migrations is migrations that can't coexist with the old code and really are disruptive. At that point, you do have to stop the app servers and put up a, sorry, we're in maintenance page. Please have some patience. Run those migrations. As soon as they're done, or while they're running, you can upgrade the code on the app servers, or better, much better, is launch new app servers with the new code. As soon as the migrations are done, you can then switch on the new app servers and move over to them. And sometimes you may have some post migrations that can run afterwards while the app servers are already running, such as adding more indices or doing some more stuff on the database. So there is some downtime there. It's pretty much unavoidable if you have the sort of standard web frameworks where you're running migrations in the middle at some point. But the nice thing is really flipping to fresh app servers, and that's the scenario we want to show in the next webinar.
And it's also possible to have fresh MySQL masters. I can have two masters in the same deployment. So I could have built up a new master for my new schema and not interfered with ongoing progress while I was working with my new master. And then when I know the new master is right for the new software, then flip over to new app servers and a new master database between the load balancers atomically.
So another question is in the rolling deployment scenario, so what we demoed, how would we remove the updated app server from the load balancer during a deployment? So what I assume this refers to is we just did an SVN code push. You may have a little bit more complicated upgrade where it may take a few minutes to load new code, update it, maybe double check that everything is working, really shutting down the app server process takes it out of the load balancing rotation. The load balancer, we use software called HA proxy. It does active health checks, and as soon as health checks fail or the server is not responding, it takes it out of the rotation. So we don't see really a big need to explicitly take it out. It's more it detects quickly that it's not operational and resends some of the in-progress requests to other app servers and switches over.
You could also go to App Server 1's operational scripts, and there are two scripts here, HA Proxy Connect and HA Proxy Disconnect. This is on a per server basis. So each server within the server array, I can go to it one at a time and simply say, I'm about ready to disconnect one. And simply with clicking this button, he'd be removed from the HA proxy. Later I could put him back with this button and put him back into the HA proxy. So yes, I can take any server within the array or any group of servers within the array and take them in and out of the load balancer. Just remember, if you take them all out, you're going to 509 your users, there's going to be nothing available to them. So leave them at least one that's sufficient to carry the load.
Why don't we, I think the initialization worked, so maybe we just move the next step forward and then there's additional questions that come in.
I had one little presentation I wanted to make here so you see what's going on. My slave has attached to my master. I have one window over here collected the master database and another window collected the slave database. So I'm actually seeing both at once. So if I go to this window right here, I can do a select on a table. And if I go to this one right here and do an insert into the table, I could insert a couple into the table. Go back to my slave. If my slave is working correctly, you can see that I've inserted these new lines. So now there's 4 new lines. Let's add another couple more.
I hope this is just a scratch table that you put in and not your app table.
Yeah. Us ops people always have a table we put on the side. In my case, it's called comments, with a table called comment. And the comments in there are things like, I got things working today, I added things. So as you can see from the view of the application server, I can really do replication from our master and our slave. And I proved to myself the slave truly is a slave of the master and it's working correctly.
Good, now we can promote it.
I'd say it's time for some promotions. In which case, roles begin to change. Now it's really important that you keep the names right, because our new slave is about ready to become new master. Okay? So to keep things ready, I'm going to change new slave to new master. So I now remember which one I'm talking about. Okay? So our new slave is now new master. There does exist an operational script ready for you to promote to master.
Oh, that's not the one.
That's not the one. Promote to master. Promote to master. Okay. What promotes to master is going to do, and please read the words up here because they're very, very important, is you must be connected to a master in order for this to work seamlessly. What's going to happen is it's going to take over the role of being the master. It's also going to do a dynamic DNS update of the DNS pointer. So the applications, the next time they open up a database, will open up this one as the master database. So I launch that command just like I did before with the run command over here. On the left-hand side, we see a promote to master is queued. And in a moment, I'll be able to see that my new master has now taken over the role of being master for this deployment.
So there's a quick question here. How do you ensure that MySQL EBS snapshots are consistent? I think what this refers to is these are point-in-time snapshots of the block device, and you really want to take those when the block device is in a consistent state, meaning the file system and everything is consistent. That's built into the way we do that. That's built into the server template. So there's a cron script that runs on all of the database machines to do the backups, snapshot backups. And it goes through a sequence of both freezing MySQL by acquiring a read lock or write lock on all of the tables, and freezing the XFS file system, then doing the snapshot, and then unfreezing everything. So that takes a few seconds to do. And during that time, the database is really frozen. So there's a, if you look extremely closely, there's a minor hiccup, but nobody really notices that. We do that currently by default, and that's all settings you can override. I think once an hour on the master, and every 10 minutes, every 5 minutes, I forget exactly on the slave. So these are some of these inputs that can be overridden.
Right, very good. So now that we have a new master database for our applications, let's go back and prove that our demo is actually still working and talking to the database. And it very much is. So we're actually filling the screen with the new variables that do look correct.
We didn't launch the second slave, so second app server upgraded, so that's probably why we're seeing the old one.
Right. We'll go back and launch the second app server.
So make sure that it's a master on the...
Okay. So let's put back our screen over here. I have to launch a terminal on new master, which is that guy over here. Okay. And how am I going to prove he's the master? Just show databases would be good enough. And you'll see that he has all the databases for this thing, but at the moment there's no running slave on him, so I can't show slave. Let's start a slave next, because we're going to need a new slave soon. Once again, it's important to quit, because when we roll things, it restarts the database. Okay? So the next job we need to do is create a new slave database. Yeah, you want to see some load?
Yeah.
So he should be seeing some load now from... Oh, you want to see it actually working? Okay. So
while you're showing that, somebody asked, what's the nature of the load, what app is creating it, and what kind of load is it?
What I'm actually doing is I'm running a separate program on a separate machine, which is our load generator, which is dumping the entire database to /dev/null over and over again. I chose this method because it creates very, very little Apache load or user load, but it creates a lot of database load. So what we're seeing is a lot of database load and almost no I/O going on between the other servers. So it's not interfering with our website, but it's sure interfering with the database, which is currently talking a great deal. So let me zoom the graph into now so we can actually see.
Would we see any MySQL ops? Or?
Oh yeah, MySQL is pounding at this point.
Yeah, these are all the date graphs, so it's somewhere there. Yep, you see all the threads.
Yeah, he's going to be really pounding.
So these are updated every 20 seconds, so it shows pretty quick that there is something going. Good.
Yeah. So we got a lot of load going on.
We have things running. It's
the first time I showed these graphs to a DBA of everything you can see in MySQL, it almost brought him to tears. You can actually see this much detail of what's going on with every single one of the database servers in your entire deployment. This is a very, very detailed analysis of everything that's going on, every operational read, every action that's going on.
Table scans.
Lots of table scans.
Create some indices, man.
Yeah, I got to create some indices. Comments has no indices. And the other great thing about this is this information is preserved even after the database server has been terminated or deleted. So if anything happens, I get the postmortem. Right. It's actually available to you through the dashboard, even if the server has exited. I can go back a week, I can go back a month, I can go back a year. So when you see a new release of software from your developer guys, and all of a sudden load goes back up again, you can say, hey, on May 1st, the load went up. On May 1st, we released new software. Great analytics. More questions?
We should maybe just wrap up the slave launch. I think we were somewhere stuck in the middle.
Okay.
So what
Let me start from the top. We're going to start from our new master, which has all the parameters we want, once again. And then this time, it's even simpler because he's actually a large with the right operating system. So we do our clone operation again. And when the new clone comes up, remember to rename them. Things are starting to get confusing because now we have a new slave.
New slave.
So now I'm going to rename him new slave. Isn't that confusing? We can put them back later when it's less confusing. Before we launch, I have a large with the right operating system that's the new slave, and he'll participate once he's launched. Ready to go? Launch with the new parameters. Okay? All these are the parameters you're talking about. This is those backup frequencies we talked about. This looks like a cron tab. I have it running rather slowly. This is a dedicated database server. And launch the server.
Quick question to interject. Can I change the size of an EBS volume?
Yes, you can.
Well, you can and you can't. You can't go and resize it while it's, whoops.
Yeah, when I set up these volumes, I used XFS, and XFS grow works beautifully. So you can go to that server and do an XFS grow. I'll have to answer for you separately on how you create a new snapshot or a new volume which is larger. Okay, but you can definitely grow to a larger volume using XFS_grow.
If I remember correctly, whoops, I'm spacing out, blanking out here. You can't grow it online. You have to create a new EBS volume that is larger.
Yeah, there's several steps involved.
Yeah, and so this would be exactly the same scenario that we're showing here, except that instead of going from a small instance to a large instance, you'd be going from a large to a large, except that you would be changing the size of the EBS volume, and that is again one of the variables that you can specify.
Right. So when I go to the EBS volumes menu, which I'm not going to complete, I'll just show you how it works. When I create a new volume, right, one of the things about creating a new volume is you pick the snapshot you're starting from, we'll just pick one, and then you pick the size. That size is allowed to be larger than the original size. So if I created this as 1 terabyte,
the only thing you do
spend lots of money.
The thing you do need to do is once it comes online is actually do the XFS grow. And
yeah, which you can do at any time later.
Right now it's a manual operation. But
correct.
We're going to put an option or something in so that you can say if at good time the volume is larger than the file system automatically grow.
That's correct. And I'll cancel this because I don't want to spend the money. When you launch a new server, there's a force snapshot within the operational scripts. If I create the larger snapshot, it'll force it to use the larger EBS-based snapshot. So it's not quite seamless, but yes, you're right. It is possible to actually grow the size of the database by flipping over to slave and growing it. Okay, coming back. Our server is still pending.
Oh, it's still pending. Okay. And anyway, this one will just launch, and then it will start replicating from the large master, just like the large master initially replicated from the small master. So that's
bingo.
Pretty much. I think we've gotten pretty much through all of the steps of the demo. While we can flip back to this and look at the final state in a few minutes. Maybe we can go back to the slides.
Sure can. In the meantime, I'm going to go back here and finish up and make sure that we're using the B schema for everybody in the very end. And that way we can finish up our rolling upgrade while he's talking. Here you go.
So throughout, you've seen that we tend to really launch the next server. And to me, that is really the cloud principle #1. Always grab the next resource. To me, it really changes dramatically the way we manage databases and our customers can manage databases. Back when I was at Citrix Online and we had multiple data centers and real hardware SAN arrays attached to big iron database servers. We had a master and a slave, and the typical scenario was that something would happen on the master and we'd fail over to the slave, promote the slave to master so that we didn't have a big hiccup in operation. And then my DBA and I would shout at each other. He would say, well, I now need to spend the next week in order to figure out what went wrong on the master. And I'd be shouting at him, hey, can you reboot the old master and bring it back up as a slave so that we have replicated operation again? And he'd look at me and say, well, Torsten, it's going to recur tomorrow and we're back in this on square one. So in the cloud, you don't have that problem, right? You roll forward to the third, fourth, fifth, whatever server. The old one you can keep around. It just costs a few bucks for a few days when you have time in order to go and do postmortem analysis to see whether it's a problem that might recur and what the cause is. This rolling upgrade, exactly what we showed you, is actually what we have also done on very large deployments when Animoto went from 80 servers to 4,000 servers over 3 days. Somewhere in the first day, we noticed that, oops, at the rate at which this is going, it's not going to stop anytime soon. We better upgrade the large database servers to extra larges when we had somewhere a few hundred servers before going any further. It wasn't overloaded at that point, but we could clearly see that at the rate at which we were going, it was going to be a problem. So while everything was running and lots of users were using the system, we did exactly that upgrade. There were some 30-odd app servers that then failed over, and I'm sure there were a couple of 504s or 503s, but users are by and large, that's a lot better than being caught on the wrong foot at the end of the day.
And from the developer's perspective, when you run into a problem where the database looks like it's overloaded, it's really nice to be able to migrate the database to a large and test it out. If it really solves the problem, then you move forward. If it didn't solve the problem, go back to the small. When you own your own hardware and you've already bought that extra large server and installed it, you spent the money, you can't give it back. Whereas now, you can simply roll back to the small server and save the money again. So it's a way to experiment with rolling forward. And another nice thing, which I like, is that when I launched that new slave database, I did a complete test of the database's backups, because that was launched from the backups. So I'm now very confident my backups are really solid.
So you saw the same thing with the app servers, and if we hadn't determined that this was just a CSS caching issue in our browser, we would have launched www3 and gone with that. And this is really something, this grabbing the next one is something that doesn't come naturally. Sysadmins, good sysadmins, have, as soon as there's a problem, they dive into it. What's wrong here? Let me fix it. Let me go fast in and find out why it's overloaded, why it's not working, why it's not responding, why, etc., and fix it and try and fix it in place. Oftentimes, those manual sort of hot under the fire moments create more problem and bigger issues than they started out as. It's easy to make it to fat finger something. So simply launch the next one. Clone a server that's known to work, launch it, bring it in, forget that damn thing that's not working right now, and deal with it later. Move forward, move to the next.
Yeah,
it takes a while. It takes us we've been doing this for now 2 years, and we still sometimes get into trying to fix it in place or upgrade in place rather than launching the next one. It's a little bit of rethinking.
Yeah, use that clone button. The clone button takes a snapshot of your whole deployment and sets it aside. You can go back later and see what was happening at that point in time and what parameter was wrong, and then continue working. With the clone button, you can always have a copy of what the current state of the machines are.
Good. So wrapping up, really what's different and what's great with cloud deployments is you have these resources on demand. When you need it, larger database server, maybe you only need it for a week because something became inefficient, and you just need to, you just need to get over the hump and figure out later what happened and fix the performance issue. You get a lot more automation. The cloud and really the APIs enable higher levels of automation. As you've seen, the bringing a new slave online is fully automated. You launch it, it comes up. And as we're going, we're adding more and more automation so that it reduces the errors and it saves time. That's really the less administration. You operate at a higher level. Things like, let's get another machine is a couple of clicks away. It's cloning, changing some parameters, launching it, checking it. It's a lot less work, less manpower, higher level tools available. And the last thing I think is very important, and for us, one of the key principles behind RightScale is that everything is transparent. You can go in and change any of the scripts, not just the variables that you've seen. We didn't dive into any of the scripts that do the actual automation. All of those are visible. All of those can be changed. All of those can be inserted into your own version of your own MySQL slave or master server or app server. And so sometimes people talk about, it's out there in the cloud. I don't really know where it is. It's sort of, they're doing stuff with it. No, that's not true. You are doing it. You're in full control. You saw the monitoring. You saw how we operate on the machines just as if it was our own hardware. It's really not that. We don't feel out of control. It's not like it's magic behind the curtain that's happening. Everything is inspectable. Everything is controllable, just like you used to with your own data center. It's just you don't need to be out there and have monkeys racking and unracking machines and pulling the wrong power cord at the wrong moment. So that's really important to keep in mind. So at this point, that's the end of the demo and what we wanted to talk about. I think we have a whole slew of questions still, and we'll hit a few of those now in the remaining minutes. All of the questions will get an answer, so all of you that have sent us a question that we haven't answered, Michael will spend the afternoon answering, as well as Matt and Eugene.
That's right, and we're going to keep the question line open even after the audio and visual portion of the webinar concludes, and Eugene and Matt will stay online and continue to answer some questions.
So you mean the chat, posting messages and get questions and answer will stay on?
The Q&A chat window, and should you have a question, should you think of one after that closes, feel free to email us at sales@rightscale.com also with questions, and we'll do our best to get those answered.
Good. What do we have here?
So let's take a little bit of a change of pace and direction. There's so many questions flying by, but about the monitoring and graphs. So there was a question of how often are the graphs updated, what's being used to collect the statistics, and will we be offering support for creating custom plugins so that app owners can get custom application logs parsed, aggregated, and alarmed on?
That were many questions at once. They are currently updated every 20 seconds, and the software we use is called CollectD. It's an open source project. The client runs on the instances themselves and send data to a centralized server or set of servers that we operate, from which we produce alerts, triggers for automation, as well as the graphs. And we haven't documented that very well, and CollectD documentation is a little bit lacking, but that will remedy that over the coming month. You can currently plug in custom values. You can plug in create custom plugins. CollectD is written in C. However, it does support Perl plugins as well as external processes that can send data. And we also are in the process of supporting custom alerts. And we will continue improving on that as time goes on. And here you see a screen with some of the alerts that are defined. So for example, if the CPU idle exceeds, what is this one? This is the auto-scaling one. So this is really from these alerts is how we drive the auto-scaling. Ed is driving here and showing me things I didn't expect. So this is an alert that drives a scale down when the server becomes idle.
So I've actually added alerts to the template.
Okay. Mm-hmm.
Okay, so another kind of, in terms of lifecycle deployment, question comes in. If I have a scalable array of several servers, tens or hundreds, how can I update the code or perform any other action across the array?
That's a good question. You can run operational scripts that now I'm spacing out whether that's in the upcoming, I believe that's in the upcoming release, to be able to run an operational script on an array. There are some limits. We won't support running it on hundreds of servers out of the gate, but we're adding support for that. I'm spacing out a little bit on where that's in the pipeline. I apologize for that.
All right, but it is in the pipeline.
Absolutely.
It is coming. Here's a bit of a philosophy question.
The other The other scenario that it again depends on whether it's a major upgrade or whether it is more of a kind of rolling upgrade. The other good method to use is to relaunch fresh servers. So you might create a new array and start new servers with a new version there and slowly ramp down the old array, or wait until they get replaced, or manually go through and terminate some of them. There's a number of scenarios here, and that's where it depends on what you can run, whether you can run old and new servers at the same time or not.
So to be clear, today, all the servers in the deployment, if they have a similar script, you can run from this. In the future, they'll be able to run this also on the array.
Great, great. Here's a philosophy question. Why ever do a rolling push? Shouldn't you just deploy a whole new farm, including load balancers, and then migrate the IPs when you're ready?
So you don't need to load. The load balancers just have the load balancer on them. There's really no need or no purpose in launching fresh ones. Many customers run load balancer and app server front ends combined just in order to save and not have 4 machines for load balancers and app server initially, which is perfectly fine. The reason to do the rolling upgrade, fundamentally, yes, you should launch new servers, etc. But oftentimes, it's just easier. It's a matter of being practical. It's just easier to just push a quick SVN up, a code update when it's just a minor fix. It may be some layout, a minor fix where really there is no big issue about is this going to break everything or inconsistency between the servers. It's just more practical to quickly run the operational script rather than launch servers and then have to rename them and delete the old ones, etc. There's just more work involved.
Yeah, frequently you just do that little news blurb. We're about ready to give a webinar today, and you just want to push it out to the website, bang, you're done.
Yeah.
Great. Well, we're approaching the end of the hour here. I think we have time for one more question, which again is kind of a process question. And it goes like this. Even though the sysadmin changes to this new roll-forward approach instead of fixing things, is there any value to the sysadmin capturing the broken system for analysis?
Oh, absolutely. And in a way, I mean, the best capture is it's still live, it's still running. You can poke some requests at it, you can look at log files, you can do and really inspect it. And that is definitely useful because sometimes the problem is hardware related. The host that the instance is running on might be degraded, may have a problem. It might be a network issue within EC2. Don't see those often, but it can happen. And then there's nothing to see, but other times there are issues. MySQL may have a problem, or the app may have a problem, or the disk may be full. And rather than go and randomly delete files, launch a fresh server, and you still want to get the data off of the other app server that was full.
Yeah, I see that as a more common problem in software. Logs full is a biggie. So launching a new server, leaving the orphan server around, going in and looking, oh, I didn't turn on log rotate. That's why I have this 15 gigabyte file in there. And then you fix the problem, and then the next time you launch, log rotate works correctly.
Right.
Great horse Morgan.
All right. Well, I noticed the clock just turned 12, so we're going to go ahead and wrap up here. A few concluding notes. One is that we will have a recorded version of the webinar up on our website later today. So if there's someone you'd like to send a link to who didn't get a chance to join us, or if you'd like to listen yourself to parts of it, welcome to do that. In addition, give notice that in January, as you can tell, these webinars, there's never enough time to cover everything we'd like to, so we are continuing this series of webinars on best practices in the cloud, and we have a sign-up link on our site under rightscale.com/news_events/events.php. And so you can just go to our website under the news section and sign up for get information about the webinar in January. Finally, we do have representatives from the account management staff, the sales staff at RightScale. If you do have follow-on questions and would like a more personalized discussion and maybe a live demo that's specifically related to your needs, feel free to contact us at sales@rightscale.com or the phone number up on the screen, 866-720-0208. And finally, as we've had since the very beginning of the company, we do have a free developer account that you can sign up for straight on the top right of our website. And we'd welcome everybody who's not already a RightScale user to go ahead and give that a try. So with that, I'm going to sign off. Thank you very much for joining us today and listening, and happy holidays, everyone.
Thank you.
Thank you very much for listening.